Hello everybody, today we're going to be taking a look at this problem. This problem is called top k frequent elements. Given an integer array nums and an integer k, return the k most frequent elements. So, for example, we have this input here, a list of nums, and we see 1, 1, 1, 2, 2, 3, and k is equal to 2. So k meaning being 2, what that means is it basically means to return the two most frequent elements, right? So what is the first most frequent element in this list? Well, obviously 1, because we see 1 3 times in this list. And then we also need to find the second most frequent element, 2. 2 is the second most frequent element in this list because there's 2 instances of 2. So we output 1 and 2. So hopefully the problem is pretty clear. Now it might seem pretty simple, but there's some trickery involved around this, right? We can't, if it was just to return the most frequent element, it's easy to do in a single iteration by keeping track of a counter, but we not only have to do it once, but up to n number of times, right? Because it could be k can be any input, right? So how will we go about doing this? Well, one thing to note is we are going to be utilizing what is known as a max heap. So what is a max heap? You can see on the right here an example of a max heap where we have a number 17 at the top. It's, as you can see, it's in a binary tree format where each node is connected to two nodes. But what we can also notice here is that each node on the lower level has to be less than the nodes on the higher level. So you see each parent node is greater than the children node. So 17 is connected to 15 and 10, and 15 and 10 are both less than 10. 15 and 10 are both less than 17. We have 6 and 10, which are both less than 15, and 7, which is less than 10. So that's essentially what a heap is, a max heap, where the root node is the largest node, and each child of that of the parent nodes are less than the each each child node is less than its parent node. So why do we need this heap? Well, a heap is an easy way to figure out the most what we essentially plan to do is store the frequencies, each frequencies, and create a max heap for each one, so we can simply continuously pick out of the max heap of the frequencies. So we can see that we want to have 3 in the max heap root position, and then the next one 2 in the next position, and you can continuously take out the max heap and then continuously work from there. So how do we do this? Well, first of all, we need to get the frequency, all the frequencies for each individual variable, and then we can go about figuring out which one to get, right? So let's start by making our function. Oops. Define top k frequent. Let's do this. And we take the list as the input and k as the input. So what do we need to get? First, we need to count the frequencies. And what is the most efficient way to do this? The most efficient way to do this is store them in a dictionary format. So we have key value pairs with the key being the number and the value being the frequency, right? So to do that, we want to create a dictionary. There's multiple ways to go about doing this, but the simplest way is Python actually has this handy package where called counter. So from collections we can import counter. And what this will do is when we say count is equal to, I'm going to make a dictionary essentially of this list. And all this does, all the counter function does, is it automatically creates a dictionary from counting each individual element and how many times they appear in the dictionary format, which is exactly what we want. So now we'll have 1 corresponding to 3, 2 corresponding to 2, 3 corresponding to 1 in the key value pairs. So there we go, we already got all the frequencies, but the key thing we need to note is we need to find a way to most efficiently get the k most frequent, the most frequent outputs, right? So there's multiple ways to do this, but essentially we want to somehow sort the, not necessarily even sort the frequencies, because we don't need all of the lists sorted. We only need the topmost ones, right? So to do this, we are going to build the max heap. So we can define this heap as a list. And one thing to note, we also need another package called heapq. Heapq in Python is a little bit strange because we obviously want to create a max heap where we have the highest frequency at the top. But Python in particular only has the capability using heapq to make min heaps. So you can only make a min heap, and you could obviously go the other way around, but that's not efficient if we want to get the highest number, highest frequency at the top. So what we're gonna do, first of all, let's iterate through the dictionary we made, right? So for we're gonna say num comma freq. We're gonna use in count dot items. So this is essentially iterating through the dictionary that we just did. Like I said, the number is the key, the frequency is the value pairs, right? We are going to use heapq dot heap push. And what the heap push function does is it essentially creates we're creating the heap, the min heap actually, by saying first where do we want to push it to. We want to push it into this list right here. We're going to push it into this list, and what we're going to do is we want to push it based off of the negative frequency. Why the negative frequency? Because the negative frequency is going to be the most, it's basically flipping the entire thing around, right? Because as we can see, if for example, if the highest frequency, like in this list here, is 3, and we want to get that as a max value, but if we only have the min value, it's going to be at the bottom. But if we take the negative of this, -3, it's actually going to be the least amount, right? -3 is the least amount, and because of that, min heap takes the least element and puts it at the top. So -3 would be the least element, and in this case, that corresponds to making a max heap using a min heap function. So we're pushing based off of the frequencies. We're going to negative frequency and num. So we're creating a min heap basically based off of the negative frequency, which is essentially making a max heap off of the positive frequency. So we got negative frequency, and we know what number it's corresponding to. So this is going to be stored as -3 and comma 1 into the first slot of our heap, right? And now that we have our min heap, or max heap in this case, because that's technically what this is, we are going to make our result list where we can obviously get our final output. We want to get our final output into a format where we list out k number of frequencies, right? So to extract the k number of things, we can say for I in range of k simply, because we're going to be repeating an action k time, we're going to be appending it to the k times. What we want to do is we are going to say frequency comma num is equal to heap q dot heap pop, and heap pop is essentially taking the first heap first element out of the list. And what it does is, you see in this max heap function where we have 17 at the top, it takes out 17 and it replaces it with the next largest number in the heap that we created. So right now 17, it goes to 15. 15 is automatically assorted made as the new root. So in this case, first it would start out as the frequency of 3, and then it would take out the next frequency would come to the top, which is a frequency of 2, indicated by these 2's. So obviously what it'll pop out is this list of frequency and nums, right? But we don't need both of them. We only need the num, because we don't need the frequency. We just want to know that the frequency and num that we just took out, we want to know the number corresponding to that. So in this case it would be 3 comma 1. We just want the 1 to be popped out, so we're going to be appending that 1 into the result. And there we go. That's how you append each individual number. Why did I say result? Return result is what I meant. And there we go. So this is our function, and at the end the result will be returned, and we should get our output list no matter how many numbers we specify. So let's test this out real quick. I can copy paste this to test out our code here. Nums equals to 113, and we're gonna say print top k frequent of nums comma k. And there we go. So let's run the code and see how it works. We can run our code and we can immediately see that yes, we do get all the frequencies listed in order 1 and 2. Now what will happen if we instead make 3 the most common number? It is going to list 3 first, 3 comma 1, because 3 now is corresponded to 4, and there's 3 instances of 1. And there we go. That's how we made our problem of finding the top k most frequent elements. Hopefully everybody here understood the heap, how we created a max heap using the min heap built-in function in Python to sort the max frequencies that we collected, using this counter package to automatically create the hash table for all the frequencies. The time complexity of the solution, if you guys are curious, making a heap in particular using the heap operation is a log n time operation. So combined with the fact that you have to make this n number of times actually here, heap q dot heap push is an n number of time operation, n times a log n operation essentially. Sorry about that. This means the whole time complexity of this solution is going to be an n log n time complexity. And it's also going to be a space complexity of n to create the heap in the first place. So hopefully you guys understood the logic there, and I'll see you guys next time. Bye.